All right, number 3 from worksheet 7. Excuse me. Find all values of x which satisfy that equation. Let's see. Oh, this is a tempting one to say, oh, look, there's natural logs everywhere. I'll just divide them out. You can't do that. You can't divide out natural logs. Once you get natural log equals natural log, then they'll go away. Then you can delete the natural logs. But before we get to that spot, we need to condense. Natural log of x times x minus 3, right? Because addition, if you're adding logs, it leads to multiplying their arguments. So natural log of x squared minus 3x equals natural log of 4. Now you have natural log of something equals natural log of something. That means the two somethings have to be equal to each other. X squared minus 3x equals 4. So x squared minus 3x minus 4 equals 0. We've got a quadratic. We hope it factors. It does. By the way, there's a change on the quiz today, and the change is made so that it will factor. Before the change, it didn't factor, and so that was a mistake on our part. So x minus 4 and x plus 1. So x equals 4 and x equals negative 1, which looks like answer choice A. Well, it doesn't look like. That is answer choice A.
You can't have a negative 1.
Okay, now be careful how you phrase that. You can have negative 1 as an answer.
But it doesn't work in this one because that would be natural log negative 1.
Right. So you don't throw it out because it's negative. You throw it out because you can't take the log of a negative.
So in this case, if like ln x1 was like ln x plus 4, then it would work.
Yes. If our first natural logs were natural log of x plus 4 and x plus 5, and we got negative 1, negative 1 would be fine.
Even if that second x would be the plus 4 and that first one would still have a negative, it wouldn't work because that first one would be less than 1.
Right. If you have to check them all. If they're all greater than 0, then you're fine. If any one of them is less than 0, like natural log of negative 1 minus 3, that won't work. So we have to throw out negative 1. So it's just x equals 4. So be careful. That's a great multiple choice question because you do everything right, minus one little thing, and your answer choice is there. But it can't be negative 1 because you can't log a negative number. One way to maybe handle these, I don't know if this would be the best way, but would be to check that first. Like, look at your answer choices, and you see negative 1, and you're like, well, I can't log a negative number, so before I even solve this problem, I could mark out the ones that had a negative 1 in them. Let's look at number 5. Oh, perfect, because number 5 is the other type of problem, where there's not a natural log on both sides. So I definitely can't just cancel one of the logs. That would have been funny if 2 was an answer. Answer choice F. X equals 2. We assumed no one would make that mistake. So what do I do if I can't cancel natural logs? I can do the fishhook thing. I can eat. So e to the 5 equals x plus 3. E to the 5, I don't know what that is, but I do see an answer with e to the 5 in it, so I'm feeling okay there. If I want to get x by itself, regardless of what's on the left-hand side, I would subtract 3, right? Regardless of what crazy stuff is on the left. So if I subtract 3 from both sides, e to the 5 minus 3.
So you wouldn't keep on going to like...
And then, you know what, I better check and make sure I'm not taking the log of a negative number. E to the 5, that's a pretty big number. Yeah, that's good enough. And if I subtract 3 and add 3, yeah, e to the 5 is a pretty big number. That's good enough. Definitely not negative.
So for this instance specifically, because they gave two choices, you wouldn't keep on going. Like, so 5 equals ln x plus 3. You wouldn't keep going because
There's nothing more to keep going. We have x equals. We're solving for x. Once we have x, we're done. Tori?
Can you go over 7?
Yes. Looks like we did 7,
yeah,
but
we did all of them.
but we can do 7 again. So I need to condense on the left-hand side. And anything positive goes in the top, anything negative ends up in the bottom. Addition leads to multiplication, subtraction leads to division. So those two minus ones end up as a 2 and an x in the bottom. So we condense it. Then we do the fishhook thing. So e to the 5th equals 3 over 2x. E to the 5th equals 3 over 2x. And then there's algebra steps to do to get from there. There's a couple different ways to go, but it looks like we decided to fix the denominator first. So that got us to 2x e to the 5th equals 3, because we cleared out the denominator. It did not get x by itself, but it at least got it out of the denominator. So that was the motivation for multiplying by 2x on this step. And then we want x by itself, so we divide by divide by the stuff that's not x. So 3 over 2e to the 5th. I don't remember that we talked about checking it. 3 over 2e to the 5th. I have no idea what that is, but it's positive. So that's all I'm concerned about. So that one would work.
Worksheet 5, number 5.
Yes.
5 plus 6.
Let's rewind and look at worksheet 5. 5 and 6. Okay, looks like we did 5. There we would just have to recognize that the cube root is the same thing as 1/3. That's probably the key to that problem. After that, you're good. 2x equals 1/3, and then you got an algebra problem from there. Although fractions, and that's where some people would mess up. Number 6. There's sort of two ways to go with number 6. You could, like right where you're at, say, well, based on like their position in the equation, 4x is going to have to equal x minus 3. Right? 1 over e to something equals 1 over e to something. The two somethings have to be equal to each other. So subtract x from both sides, divide both sides by 3. Is it okay that I have -1 as an answer? It is, because I'm not taking the log of anything, so it's fine.
So if there's no log or ln, then
If there's no logs to start the problem, then you don't have to worry about checking.
so x would equal -1, just right up.
So that's it. X equals -1.
That's what you have to do.
He's talking about worksheet 5.
This is worksheet 5, number 6.
We do 4. Let's do 4.
On this worksheet? 4 throws people off because there's a 3 and a square root. What is this? How do I rewrite
2 over 3. Or 3.
1/2? I'm going to show the extra step. It does turn into 3 over 2. Right, you got flower power. The root grows in the bottom, the flower power grows in the top. So 7 to the x equals, and then power to a power we multiply. So x equals 3/2. Okay. 14 on which worksheet? On worksheet 6. 14 on worksheet 6. Let's see. More condensing going on. Also, if I'm thinking about negatives, I'm thinking about what I said earlier. Like I can't take the log of a negative number. 4 times negative 1/4 would not work. So that would be out.
And same with E.
Same with E. So I'm already got it narrowed down here. Oh, yep, D's got a negative in it too. And 4 times negative 1/2 would be negative, so D's out. So, goodness, 50-50 shot, even if I don't really know how to solve the problem. Let's move the 2 up. Log base 2 of 4x squared. And then let's condense. So log base 2 of, and I'm going to go ahead and square the 4 and the x. 16x squared over 2x plus 1 equals 1. What do I do next?
You just do the
The fishhook thing. So 2 to the first equals 16x squared over 2x plus 1. Multiply both sides by 2x plus 1 to get it out of the denominator. So 16x squared minus 4x minus 2 equals 0. Right, I distributed the 2 and then subtracted it over. And then I would factor out a 2, make life a little bit easier anyway. 8x squared minus 2x minus 1. Let's see, it's got to be 1 and 1. Factors of 8 are either 1 and 8 or 2 and 4. 1 and 8 is not going to work. 2 and 4 will work if I get the signs right. Let's see. I think I want the 4x to be negative and the 2x to be positive when we FOIL. That way I'll get a negative 2x out of that. And now we can kind of see, well, 1/2 or 1/4, we're going to get one of those. So x equals negative 1/4 and x equals positive 1/2. We already said the one negative won't work because I can't take the log of a negative number.
So there's going to be 1/2,
so it would just be the 1/2. So A.
You said we're not going to have any graphs like 16, 17 or anything like that.
Correct.
How would you, did we do any 16 or 17?
Well, that's from old stuff. That's just to try to remind you.
How they go.
For e to the x, that's where we want to pick negative 1, 0, and 1. So negative 1, comma 1/3, 0, 1, 1, comma 2.7. There's e to the x. Natural log of x was a little bit trickier, maybe. We wanted the base, we wanted the argument to equal the base, so that would be e. And we want the argument to equal 1, because the natural log of 1 is 0. The natural log of e is 1. So 2.7 comma 1, 1 comma 0. That's only 2 points, so if you don't know what the graph looks like, you might sketch it in wrong from there. But hopefully you graphed enough of these initially to remember what the graph looks like. That's not on the quiz, but it is on the test, and we haven't seen it in a while, so worth seeing real quick.
Will we just have to draw the parent function, or will it be like alteration?
It'll be both, kind of like the first test, where that way you can use your parent function stuff. So like we'll have you graph the parent function first, because most of you are really good. If you have a parent function, most of you are really good about knowing how to slide it or flip it, all that stuff. Algebra 2 does a great job of hammering that into your brain. Okay, we've done a ton of worksheets 7, 6, 5, and 4 together. So any final thoughts before we start the quiz?